Kenny is basically from Nigeria, and after knowing all these our efforts, how we are providing the trainings and coachings to the needy people, so he was impressed with our mission, and he itself took the responsibility that I will handle the total Africa continent, spreading this voice. I think he is organizing a free training for his institute also very soon. So I will provide the training to their distribution company, and probably we will run along together. And definitely he is working well, and we will work together for this Africa continent. Okay, thank you, Mr. Tunde Yekini. Welcome here, and we will continue. Okay, so what we do means there are our partners basically. What I said earlier, I just want to introduce our partners. Means when we have started this training programs, coaching, all these things, people are connecting with us because they want also the business development, or they want to learn something. They are taking the training. Okay, all these things they are asking us. So I just want to introduce PYTS, PYTS China, that is our partner. Basically, they are the BESS supplier, normally for residential and C&I purposes. Commercial and industrial customers, they supply. Very good product it is. Okay. It's total, I will show later. Okay. That is for business development we are looking here. Chintian, China, that is the total solar panel production line equipments. If you want to install a factory for the solar panel manufacturing, you want all equipments to purchase, all equipments at one place, complete, even on maintenance also, operation maintenance, installation support, and you can purchase everything here. Training also can be provided. You can visit to China with us and to understand the assembly line and everything, quality and everything. Okay, so that is the another thing we have done. Another is the Agastya Hydrogen USA. Recently, we have collaborated with them. That is they are coming with the BESS, battery energy storage system, with sodium ion battery, which is very cheap in comparison to lithium ion, because lithium is not abundant. There is ultimately lithium will finish someday, and it is also costly. So sodium ion is very abundant in India itself, because it can be seawater, it can be taken from there. So with this battery pack they are coming. And regarding another thing, the product is the AEM based portable electrolyzer plant. Actually, they are just like very portable. I will show later. So they are just for training and business development. Adani Total Energy we have connected recently, and we are under discussion with them. They are installing electric vehicle public charging station. They have a huge expansion plan in India. I think 75,000 EV chargers they are every 25 kilometer in the national highway, every 3 kilometer in the urban. This EV chargers should be there. A time will come when the government will restrict this diesel and petrol and gas vehicles once the infrastructure will be there. So all are working. There is a FAM and FAM 1, FAM 2. There are scheme for EV to promote them. L&T EduTech, we are training partner for the L&T EduTech. Okay. PSCC, Power Sector Skill Council, we are training partner for them. NSDD, National Skill Development Corporation, our RDTC is the training partner as of then, not only drivers, but also as a allied service for green energy, means green hydrogen, as well as the for solar. So we have collaborated with the TU Renault, and they are starting very soon the training there. Tata Communication, we have become the training partner. We have to provide virtual training to them very soon. Within next week, or maybe within 10 days, we are going to provide a great training to them on basically on the open access. Toshiba, we are under discussion. They are already very good in the BESS, but now they want to manufacture in India itself by procuring different items from India or from outside. Some technology partner they are seeking. I am supporting them to search this BESS technology partner. So further, they also want the training. So we are just talking to them with Toshiba also. Stieg Energy Germany, I am recently just a good news to you that first international seminar I have attended Even I can show you the message from the CERC, Central Electricity Corporation. They appreciated. They messaged me that I heard your presentation PPT was very good. Can you share that one? So I just told them yes, I will share, but you just arrange a training program. Even CERC, you as a central regulatory authority, they are asking. So you can understand how we are approaching. Another thing is a matrix. Recently, we are under discussion with Matrix OPEFIL, Israel-based company. They are behind us for their product. They are basically the digitalization, software and computing solution. Okay, in the asset management as well as the project management also, we are under discussion. Recently, before 2 3 days, they approached me. They are behind me, but I have no time to discuss more and more. But yes, another thing is we are already finalized. This is the AI Free School Mumbai. They are basically in free refrigeration, all these things, but they are now coming with the BESS container. So they want my means guidance and business development as well. Adani Construction, we are already connected with them. They are into civil infrastructure. Right now, they are working at the MP and developing the huge civil infrastructure for the cement industry. That is the for Adani infrastructure. To be incorporated, that is for solar rooftop. It's a new incorporated company. We are just discussing with them. RE EPC project they will do. But RDTC Singaul Ajmer is my own center. This is the regional driving training center and green energy training. There is a means we are only the institute in India who are with the international accreditation, and we are also going to India's not the world best R&D lab there. How the human behavior can be changed, or how the road accident can be minimized. We are working for that. Another is our NGO, that is the number one NGO of Rajasthan, that is the Rajasthan Sadak Suraksa Society, which is done multiple unique projects. Right now, the helmet incentive program is going on where the users are getting a helmet, IS 4151 helmet, steel bird make in only 25% cost with the help of CSR of some corporates. These are some of our partners. Next, what we do for solar PV? What can we do? What we do for solar PV with our partners? Technical due diligence on behalf of lenders as well as investor, techno-economic feasibility, conceptual studies, yield projections, specification of large scale PV installation, check of construction operating contracts, supervision of construction and progress monitoring, participation in acceptance test, means quality inspection of all these FAT and at vendor place as well as site, verification of electricity yields during operation, other PV related technical advisory. What earlier I saw, this is the integrated, you can say, residential BESS. Lithium iron phosphate is the battery. Okay, with a depth of discharge up to 95%. Very good product. That is from China. Pi Station 230 is the model. And it can be integrated with solar, wind, diesel generator, and grid. All the round the clock RTC power can be achieved. This is the specification you can see. PCS, power conversion system, battery, liquid cooling is there. Okay, DM water plus some glycol is mixed. EMS energy management system is there. Means it can charge, discharge as per the grid requirement, maintaining the frequency and voltage. The EMS work accordingly. And firefighting, okay, all in one. And battery management system is there, which control the state of charge, temperature of the each and every cell. Okay, this is the rating you can see in the screen. This is a 105 kilowatt, 2 hours storage is there, 230.96 kWh. This how it can be integrated. Users, factory, bank, residential colony, hospital, school, where the load is around 50 kilowatt, 100 kilowatt, you can purchase this one. Or it can be integrated with rooftop solar, grid, diesel generator, charge. Now the rooftop wind is also coming, so we can integrate with that also. This is the Chintian product, what they have shown here. You can see how the frame, the top part, this is the actually solar panel basically. Okay, here you can see frame, then tempered glass, EVA, and insulate solar cells, again EVA and TPT backplane. These are the product total assembly line. You can see 500 megawatt production line kit layout. Your fully automatic stringer. What are the parts of the production of the solar? If you want to solar panel, you want to produce the what are the parts? You can see here. Fully automated stringer. One equipment is the stringer. Another layup machine, glass loading machine, EVA cutting and laying machine, 90-degree turning transfer machine, buffer machine, transfer machine, template placement machine, bus bar soldering. Okay. Secondary EVA, TPT cutting, laying machine, double glass laminator. Recently, we got a inquiry from this Chintian that is for laminator. The company is from Chennai basically. We are arranging meeting with them. EL testing machine, horizontal rotation machine, mixer feeder, lamination machine. Okay, all these are machines which are used. A complete automated production line equipments are there. So anyone want, they can approach Prayasri or they can approach to directly to Chintian also. No worry. These are the machines shown. You can just see auto slicing machine, soldering, bushing machine, auto layup machine. Okay, all these are machines which are used in a panel manufacturing. What digitalization? The OPEF. Recently, we are discussing with them. They are into automation. They are into digitalization. Okay, so predictive maintenance, asset management, all these things can be used. How they do, we will can detail. We can later. Okay, predictive industrial process, effective and efficient remote data gathering, camera, sensor, drones, IoT, computer vision, satellite, everything is there. TPM, total productive maintenance, advanced TPM, total productive maintenance, based performance management, AI, automatic AI assistance for interactive dynamic development, planning and development. So now the things are moving like that. Everything cloud control. At home on the mobile, you can maintain this. You can say how the culture. These are the designations now are coming: the IT manager, end user, engagement manager, UX designer, data scientist, engineer, machine learning engineer, O&G expert, SME, product owner. These are also there. We are talking about doctor, engineer. No, there are thousands of types of now the prompt engineer in AI. You can say the prompt engineer is also there. They are earning crores, not in lakhs. Okay, you can see. So this is the great product we are under discussion. This is the Agastya hydrogen portable AEM electrolyzer. This is the specification you can say. Why we are connected with them, because they are this product as well. They are coming BESS, which is the best means the market BESS right now in India for 2025. They are coming with sodium ion. Okay, R&D is going on. Very soon they will declare. Right now I don't have detail, but yes, with the improved energy density, they are coming. This is the portable. You can install anywhere. Give input the water. You will hydrogen will be there simply. Okay, electrolyzer plant is there. Portable. This is the specification. Okay, now we just I want to clear about solar PV. We have to understand what is the total installed capacity of India. 462.2 gigawatt. Out of that, 46.8% is renewable energy, and by 2030 we are reaching by up to 50%. 50% renewable and 50% oil and gas, means non fossil fuels. That is the coal and gas. Okay, so in PV, if we see, that is accounted 21.2% of India's total installed power capacity. Means solar PV itself, 20% energy right now is the solar, you can say, or overall renewable energy 46.8% at the end of the December 2024. This marks 10.5% increase from the previous quarter and 57.2% rise compared to December. Means you can see in 1 year above 50% increase in the installation. Renewable energy sources, large hydro comprise 45 total. It is one. Okay, total renewable energy is 209.7. I think 214 gigawatt it is reached right now. Okay, so that I have the wind energy less, but okay, 48.2 megawatt, contributing 10.4% of the total installed power capacity. 10 point means 50% is wind. Whenever we talk about solars, 50% in the wind. Other one is the large hydro. Okay, biomass in that conventional energy sources accounted for 50.46%, conventional type के, okay, oil and gas. So India is witnessing a transition towards renewable energy. We know very well. Okay, key information again, same thing is shown here. Here to you, what is the global trend also you see. China installed to 77 gigawatt of solar capacity in 2024. Only in 1 year they have installed 277 gigawatt. You can see we have installed around 24 gigawatt. Okay, in 1 year. How they are total? You can see China 886.66 gigawatt. Okay, bringing total installation. Large scale solar in the European is projected to 25 gigawatt in 2025. Means in whole world that this solar is coming very double to wind, you can say. Technology advancement, TOPCon and hybrid passive weighted back contact HPBC. Okay, technologies are gaining traction, enhancing efficiency. India's solar module manufacturing capacity expected to grow 120 gigawatt by 2025, because PLI is the production linked incentive is released launched by the government. So now production is coming fast. With the revised to this efficiency policy and market trends, okay, the US is also expected to. It means everywhere is that this solar is growing. This is the optimal mix. Earlier also I have shown in my last slides. You can see solar power is around. If you will see the energy mix by 2029-30, what will be the scenario? Solar power itself will be around 36%. Wind itself 12.2%, means if both will be 50% around, wind and solar only majorly. And coal and lignite will be 30%. Right now it will be 54%, 50 to 54. It will be reduced by 15%. It will come to 13.8%. Another major, you can say hydro is the major. Okay, 6.6%. BSS will also come there. 5.1% is the BSS. That I have already. By 2070, we are planning net zero, means no carbon emissions. Okay, and total targets, if we see, 280 gigawatt solar and 140 gigawatt by 2030 we have to install. This is the scenario in 2070. What will be the scenario? This is the 2047 scenario where 73% will be green energy. These will be nuclear 12%. Nuclear also we are, fossil fuel will be only 15%. This is again I have shown the scenario. Solar and wind. You can see here 4,000 by 2070. I am telling 4,000. It is a gigawatt basically. By 2070, 1600 is a wind. Yeah, this is only a single diagram. Earlier I have shown. Simply you can say these are the solar field basically. There may be string inverter, or in this case there is no string inverter, only the centralized inverter. Central inverter will be in the ICR. Okay, so how this string combiner box will be there, the DC cables will go there, and then the IDT in inverter duty transformer, then it will go to VCB, vacuum circuit breaker, and from this to through 33 cable it will go to cooling substation. Different ICR, maybe 12 megawatt each or 16 megawatt each or 18 megawatt each, based on the design. This is the way. Okay, this is underground cable or maybe there no pole line or whatever. These are the IDT 800 by 33 kV. PPC power plant controller, earlier also I told, now the BESS is also introduced. So if either solar plant, means inverter itself, either WTG, they have, or BESS, all have their own energy management system. Okay, and other thing will be for reactive power compensation, capacity or inductive both, StateCom may come or SVG. All four parts will be integrated with the PPC, power plant controller. So that will be taking the grid. This is the grid interface point, POI, point of interface. Here it will what is the grid voltage, frequency, what are the grid parameters through the and even the quality parameters also. Okay, harmonics, everything that will be come input is given to this PPC, and all these three will be given the input to there. So how it will voltage, it will see the grid situation, and accordingly it is coordination with the LDC. directly connected with LDC. So how it is overall the cycle, you can say grid will be made stable and monitored all the time. This is the way. Key issues now, when we are talking about the huge means we are 50 gigawatt every year by up to 2028, the bidding to be done. This is the target of SECI. But at the same time, are we installing the project in same, yeah, execution delay is there, because we have to reach by 500 gigawatt by the 2000. This offshore wind is different, that also different, that is 30 gigawatt. So what are the key issues? Land acquisition and permitting. If land is available, power evacuation is not available. Land where we have to take, where if we are installing solar, the radiation should be there. If we are going with hybrid, then we have to see trade-off between the wind velocity as well as the radiation, solar radiation. Then only we can maintain the CUF. Okay, so this is the land acquisition and permitting, mean permission and permitting and approvals. Intermittency and grid integration is, it is very important. Now you can see the this is load dispense centers. They are asking, government is asking, even the state is also asking SLDC. They are asking PMU, hazard measurement unit. They are asking PPC. They are asking capacitor bank or SVG, static var generator, whatever, STATCOM. They are asking HVRT, LVRT in the wind farm. They are asking this all reactive power control. Okay, so means in solar or wind, everything is very digitalization also. And even in coming time, the control they are going to take. If there is an issue, they will regulate power machine. Okay, transmission infrastructure, that is another issue, because accordingly we are installing, but transmission curtailment is there. Right now, every project is there facing the curtailment. Okay, that is financing investment is another issue. Policy and regulatory working well, but still improvement is required. Technological challenges like BESS is a new technology, and another R&D is going on. So that is also important. Land use and environmental concerns, skill development. Skill development is very, very necessary. People are there, but they are not skilled. Need huge and huge thing, and government, the CE is planning. Already, I think they are mandating that each and every professional working in organization should take training from the recognized institute like Power Sector Skill Council. They should take training, yeah, either NICE, National Institute of Solar Energy, okay, or through NSDC training partners. Like we are also the training partner, RDTC Singapore. So everyone should take training there, skill-based training they should take and get the certificate, because skill development is very must. Okay, misconception kya, intermittency concern. These are the misconception. With solar and wind is the intermittent power is daily it cannot maintain. Why we are coming the storage? That is the reason is that because you cannot predict. Forecasting and scheduling error is again a big challenge. We cannot forecast properly. So proper forecast with AI based, using the AI tool, we have to forecast with the history. Okay, then only we can manage the grid in this intermittent. When the integration of renewable energy will increase, may it will go up to 70% and then 100% by 2070. At that time, total intermittent power will be there. At that time, the storage will work very well. So how we have to maintain the grid, that is important. Another perceived high cost, because costing we have seen 2012 to 2020 around 80% cost is reduced. Same in BESS. Right now it is costly due to the lithium batteries, but it will also very soon when our local production will start, local assembly will start, this cost will also reduce. Land use misunderstanding. Okay, uh, we are talking about the hybrid, but what actually happening? The wind, whatever, like 6 acre wind we are taking for a 3 megawatt project, but we are not installing solar there because the shadow effect is there of the blade. Okay, so all these things are there. A separate land we are taking for solar. So that is the grid stability worries, regulatory complexity, capacity limitations, all these things. Okay, this is, you can see again, project execution challenges. What I have discussed, same thing is there. Regulatory and I just in the pie chart I have shown. But procurement is a logistic is also another lead time. Like for transformer, power transformer, the lead time is 1 year. Right now, even there are a lot of projects are coming. So there is no time to store as an inventory. So this is happening. Okay. Same the other like inverter, you can say inverter and other costly items, whatever you can say, tracking system, political and ROW issues, safety quality is also today's 27 January. I think you have seen the MNRE has launched the total BIS standards. Okay, for all materials, all solar PV materials, they have released the standards. We have to maintain the quality and safety, both things. The financial constraint is another issue because loan is very costly in India. Small players are cannot install as much. Kusum Yojana we can see, and they are not running so good. 22nd January, PM launched 1 crore this solar installation rooftop, but around we reached around 10 lakh or whatever. So speed is required, no? So that some problem is there. We have to attack. DCR is the issue. I will later I will tell you. Land acquisition and site selection. Again, there is a difference. Power irrigation is there, land is not there. Land is there, but fragmented land, especially in solar. Okay. Same thing. What impact if execution is delay? Like you have started project, but and started purchasing the materials. That is the inventory because you have not received the grid connectivity. Okay, if grid connectivity is there, the land is not there. So in this case, your fixed charges, whatever the staff you have put there, inventory, you material, some material you have procured, the inventory cost is there. Okay, debt, if you have taken the on interest, that is the interest is also there. Warranty period is also, if you have taken any material, the warranty period cannot be extended for long time. Rework cost, political issues, fixed cost, contractor idling cost is also there. Contractor is mobilized, but there is no work, there is no land, or there is no material. So that is idling cost is also there. Okay, project validity risk, uncertainty cost, machinery idling cost, capital mismanagement. Lot of issues are there. Yes. Now we talk about the solar. Solar, there are two types of solar basically. Solar PV, okay, solar photovoltaic. We generate the DC. Another is the concentrated solar power, which is directly this is depend on the DNI. This is the global radiation. Actually, solar PV is on the global radiation, GHI, global horizontal radiance, and CSP is basically DNI, direct normal irradiance. Whatever the radiation coming directly to the this mirror or whatever. Okay, that is called the CSP, concentrated solar. That is called solar thermal. Also, they actually what they heat the water and then water is then pumped to the water steam generator. Okay, then Rankine cycle, our normal thermal power plant. Generator is there, turbine, steam turbine, generator, all these things is there. Same happens in all these. Four technologies is there: linear Fresnel, parabolic truck, disk trolling engine, and central tower. Okay, and in solar PV talk, it is not going on. In 2012, there are one or two plant is only operational. Their CUP is also not coming as required. It is very less and it is very costly. At that time, it was 12 crore per megawatt. Right now, with thermal, because without storage, if you are going with this solar thermal, means there is no mean. So if you go with storage, around 15 crore per megawatt is cost. So no one is going. Even solar or wind, I am coming with 5 crore, 6 crore per megawatt. Wind is 6 crore, for example, but that is 5 crore or 4 crore. So why I will go with this solar thermal? But still, government is trying because we have to approach all technologies, even geothermal also. This is the floating solar. This is the rooftop solar, ACDB, DCDB inverter. You can say simply. Okay, these are the only part. And now wind is also coming. You can integrate a solar rooftop with wind. In Karnataka, there is a policy. This is the floating solar. It can save the evaporation of water also. We can save the water. Means the water evaporation is also the type of greenhouse gas. No one know this one. It is not so hazardous, but it is also a greenhouse gas. Water evaporation. So that can be avoided by this one. This is the ground mounted. We know very well. Okay. Yeah, why solar wind hybrid is beneficial? Already I told that power evacuation, like extra high voltage means EHV line, grid side line bay, and pooling substation. That may be common for wind and solar. Okay, this is the benefit. It saves around you can say 6 to 7% costing is saved. Okay, and PLF is also improved because wind is 24 hours, solar is in daytime only. The overall PLF, if we talk about solar, that is around 22%. Wind is around 40 35%. Total overall average comes to around 55 to 60% also it can come. Okay. C&I customer can leverage the benefit of both RPO. RPO is also solar RPO is different and wind RPO is different. So if we go with hybrid, then both can be leveraged by the C&I customers, commercial industry, factories or whatever. Okay. Continuous generation with storage. If we are going to round the clock, if only solar and solar with BSS, that is the FDRE, farm and dispatchable. Solar, wind plus BSS, yeah, with any other storage, we can round the clock power. Okay. Optimal utilization of scarce land because same land there is no two lines, there is no two PSS. Okay. This is the way. Per megawatt we can save 84 lakhs. AI application. Site Philip, right now, the project, any project, either solar, wind, any project, if you start, first thing is the site feasibility. Radiations you have to see, logistics you have to see, line length you have to see, where, how far the grid is there. All this and land development, soil testing. After soil testing, you also the foundation cost, you can say, leveling, earth grading. All these things are site feasibility assessment is must. If we use the AI or drone camera, so weather patterns we can see, topographical map, machine learning, all these things. Okay, manufacturing optimize in solar module manufacturing also we can optimize through AI driven predictive maintenance and dispatch. This is the asset management basically, operation maintenance, performance tracking. You have 1 year data. Okay, but if manually you want to check when the breakdown was there, you cannot check. But through AI like chat GPT or whatever other tools, you just put all data there and you just give the prompt that please tell me when the this was the value of this parameter. Automatically it will trip for 1 year data. So this is the use of that, and accordingly it automatically take the decision. Performance tracking you can see, troubleshooting, all these things can be done through the AI. That to be used in the security also, the AI is very useful. These are the nodal agencies. CTU is the basically central transmission utility at central level, like PGCL. We connect at PGCL, Power Grid Corporation of India Limited. That is the CTU connectivity. STU, state transmission utility. Okay, where the like Gujarat is the Gatco, RRVPNL is the Rajasthan, like that. MSCTCL is the Maharashtra, MPPTCL is the MP. Okay, all these things. Nice R&D for R&D in this solar inspection also. That is quality inspection and all these things for this ALM also. The nice is nice also do that one also. Okay, approval, this ALMM approval. Through MNRE it happens. So NITES is the agency approved by the MNRE. CARC, Central Regulatory. CI, Central Electric. For any SECI projects, any centrally connected project, only the electro inspectorate comes from the center. That is called CEI. And when he come from the state, we call it the CIG. Basically, this is the wording. NIVE is the for wind. IREDA is the finance for finance. SECI, is the nodal agency for all type of renewable energy project. And another ISA, International Solar Alliance, already I have told. Okay. The Rajasthan, I have just simple. For every state has a nodal agency, like JEDA, Gujarat Energy Development Agency. Okay, MEDA for Maharashtra, RREC for Rajasthan, like that. PEDA for Punjab. State law. Every state has the state law dispense center who monitor forecasting, scheduling, metering. This is the billing. Billing is also done through them. AMR is also there, automatic meter reading. Okay, all these things means billing is done through the SLDC, and they are continuing to interact with our substation operator that any deviation is there in the forecasting or whatever. Okay, wind, what the even weather monitoring data, and even our wind or inverter data also they collect. Okay, safety complexes you all know. Emergency is a training program mock drills. I think this slide should become last, but okay, safety is must. So we should discuss about this one also in short. Some training programs like GW is for height work. It is necessary in normally in wind farm, but yes, everyone should be safety inspector, either the project engineer or either safety engineer. Okay, mock drills we should do. Road safety also we need to understand. Shutdown and restoration process, safe process, safe charging. Then documentation, safety documentation was PTW, permit to work, job safety analysis, all these things. We should know TBT, continuous monitoring and safety measures. Periodic maintenance of plant machinery, PPN, protective equipment, personal protective equipments like this, reflective tape, helmet, safety shoes, all these things. Okay, TNP, any instrument, tools and plants which is used, third party inspection. These are the safety complexes. Yeah, this is a simple photo I am showing. This is the fixed structure, okay, not fixed tilt type structure. This is the IDT, inverter duty transformer. You can see these are the cables coming from this one. I think it is a string inverter. This one the string, string inverter. This is the SC cable basically directly coming from the field. Two winding is there, LV side. Okay, that will this idea will give 33 kV level. Then it will be controlled through vacuum circuit breaker. There is a protection or current and earth fault protection. Then it will through underground cable or maybe overhead cable. It will go to pulling substation. This is a particular ICR, 12.5 megawatt. Power evacuation, just simply I finish it. Power evacuation feasibility study, grid connectivity system study, Peace card, PSCC, okay, all these things that we need to first time charging permission. These are the LVRT, HVRT, WTG, for example, okay, all these things. LDC, how we are PLCC, we said Forte is a fiber optic. Now every transmission line we have a ground wire, simple seed wire is there. They are removing that one now. Fiber optic OPJW is to be laid. Okay, replace. You have to replace, and you have to install Forte panel so that communication can be had in 8 milliseconds. The data can be transferred. Other source the reset PLCC they are taking much time. Okay, so these are now obsolete. PLCC is redundant, but ultimately Forte you have to install. If Forte is there, PLCC also you need to install as a redundancy. Other protection will be here. No? Data and protection, both things. Conductors, all these things. Meter also, power quality meter, this interface energy meter, tri-vector meter, AMR, automatic meter reading, PMA, phasor measurement unit, PPC, power plant controller, static var generator, capacitor. So many in the grid digitalization, HVRT, LVRT, lot of things has come. Okay. Same here. This is the solar farm. We discussed the inverter IDT. Okay, already we have seen this. The PMU I have shown here. Line loss is also important. Line apportion. What is the line apportion loss optimization? Okay, SLDC. What are the parameter we have to send? This is shown here. Normal data, analog and digital. Two types of data: analog data and digital. Digital then on or off means isolator close or open. That is a digital data. Breaker close or open. That data called digital data. Real time. Okay, that's to be sent to the SLDC. Real time data should go, or if any data is not going, they call you or email you directly. Or analog is the value. What is the megawatt? What is the MVR of the line? What is the megawatt MVR of the power transformer? Every feeder, even in every machine also. Megawatt reactive power, MVR, megawatt current, voltage, first voltage, tape position also sometimes. Okay, some SLDC also ask SLDC or SRLDC, middle of central load display center, weather monitoring data also. Like for wind farm is there, so for wind farm, solar radiation, you can say. Okay, these are the things. Sorry. So you are getting now whatever I am saying. If you are getting the in chat box, say yes. I want to see basically. If you are getting some information, Yaswant Singh Rathore said yes, good. I want to Mr. MP Alam. Yeah, very good. Okay. There are 100 slides. You have to stay with me. Okay. Very good. Suresh Babu, yes. Okay, let us good, good. Now we should continue. Okay. These data already I have said. Okay, yeah, these are the NIPS. This is a new thing, not the CTU S2. Just I just told you power purchase agreement, power sale agreement, open access. You should understand everything. You know what I why I want to say this one. At least we should understand all these things. Okay, substation automation system, wind SCADA, how inverter control this voltage and frequency of the grid. Okay, that we should understand. Main bus, transfer bus, bus coupler, all these things. Okay. 1 minute. Yeah, this is the AMR scheme basically. Okay, AMR scheme shown here. Automatic meter reading. Okay, this is the check meter. This is the discom meter basically. For AMR is actually the data meter data to be sent to SLDC. Okay, any load dispatch center they require real time data. For that, we take the CT from this check meter, which is a commercial billing. That is all are ABT meters, but for commercial that is a discom maintain that one. They are sealed, seal it, but these meters are not sealed. AMR panel. These data through DCU, data concentrator unit, it is sent to SLDC. You can see. Yeah, some central. I'm short. I'm briefing. One thing is the PM Kusum. There are total three components: A, B, and C. Okay. If someone asks you to one for solar pump, already a pump is there, but it is not. It is running on electricity grid power. So that is solarization of that pump. Another is a pump is not that the solar pump to be installed. Or component A is only the farmer has any barren land is there. They can install within 5 kilometer boundary. There is any substation 33 by 11 kV substation is there. So they can the discom release a list. You know, how much capacity is available there. Accordingly, you can apply. Okay, either farmer itself can install or through any developer by giving the land on lease or any other contract, they can do that one. Okay, around 3.14 or 3.2 by the MP is the highest for 3.25 rupees per kWh is the rate. Okay, some detail is from here. Another Pradhan Mantri Suryodaya Yojana that is on 22nd January 2024 it was released. 1 year is completed. You can say some issues are, I mean, not issues, but okay, because whatever the government subsidy is there, any either it is open access, either it is Kusam Yojana, either it is this Pradhan Mantri Suryodaya Yojana, PM Suryodaya Yojana, all are you have to use DCR, domestic content requirement means DCR means you have to use the India make modules only. They are costly, around 10 rupees per watt. They are costly. So ultimately, this thing is happening. But okay, the time will come because the manufacturing under this PLI scheme, the manufacturing will increase. Then this will come. Okay, these are the PM Suryodaya Yojana flow chart is there. You can see in the website also. If you will go in National Solar Portal or this website, you will find this one also. How you have to register. Same vendor empanelment flow chart is there. How you have to, if you want to empanelment yourself, okay, the vendor to approach DISCOM and submit application form with necessary detail like PAN, GST, and contact detail. Self-assisted contractor license. You should have Class A license. Then performance bank guarantee of 2.5 lakhs to be deposited, 5 years validity. Then further vendor would be intimated and updated by DISCOM. Okay, any residential consumer every month. Vendor to follow CE and MRI. Okay, vendor will be perform free maintenance of. This is the condition. If you are installing any solar rooftop, any home, you have to do maintenance also up to 5 years free. Okay, these are the key challenges for rooftop solar vendors which are doing this PM Suryodaya Yojana. Benchmark cost is very too low, 60,000 per 3 kilowatt, not reflecting actual market condition. Vendor incur higher cost, that is a 75,000 per 3 kilowatt system, rooftop system. So there is a 15,000 difference. Why? Because the significant rise in domestic content requirement, DCR module cost. Okay, non-discharge models are cheaper, but they are costly because right now in India there are no much competition. Okay, public misconception is also subsidy management. Example, subsidy for 40% of 60 km, 40,000. Okay, for 24,000. Leaving vendors to bear the majority of cost. Subsidy is very less. That's why this is not running very fast. Material purchase DCR model 75,000 per 3 kilowatt system. Already I told you. This is the government scheme. Business and job opportunity you all know very well. Carbon credit also you know very well. Okay, it is given 1 ton of CO2 and 1 CR certified emission reduction. Carbon market is coming very booming. Pan globally it is coming 2026. These are the greenhouse gases: methane, CH4, nitrous oxide N2O, carbon dioxide CO2, HFC. Okay, AC from AC it is released. Hydrofluorocarbons, perfluorocarbons, and sulfur hexafluoride SF6. Bifacial and monofacial. Okay, what is the difference? Anyone can tell? What is the difference in bifacial and monofacial? Anyone can unmute or tell me what is the difference between bifacial and monofacial? Anyone want to tell?
Hello, sir.
Yes, Dinesh, tell me. What is the
Yes, sir.
difference?
Yes, hello, sir. Good evening to all. So bifacial, we can generate energy from both side module, and the efficiency of bifacial panel is higher in comparison to monofacial.
Good.
This is the
So
also
how much efficiency increased by using that one?
bifacials efficiency is around 22 to 23%, in comparing monofacial around 19 to 20%. Also, cost effect is also there. Bifacial is costly in comparison to monofacial.
Okay.
Yes, sir.
Okay, good. So you here you can see the here. Okay, this is the frame, same front glass, same. This is also same front encapsulant. This is the monofacial set. This is the bifacial. Both side. Okay, module both side cells are there. They are basically the radiation which are coming to the ground. They should reflect and go backside. They will also generate the energy. 30% around energy gain is there. Okay, this is OPQ or this is the transparent backside. 16 to 17%, and another is the monopark. What is the difference? You can see the how they looks. Also, you can see 16 to 17% is the polypark, or mono is around 17 to 19. How it is increasing continue, half cut. Every cell is cut in half. Okay, by increasing the area. Monopark 18 to 20%, and monopark 90 to 21.5%. Monopark MBB, N type Topcon, it is running very right now. Topcon 21 to 22.5%. N type HGG also come. It is 23%. Okay, highest. And another N type back contact. This is the latest one, 24%, up to 24%. Payback period calculation. Just see here. I just calculated for 1 megawatt. This is around 2 crore 95 lakhs. So you just see how the unit 70 lakh generation is there. Cumulative you can see degradation for first year 0, second year 0.40%, then continuously up to the fifth year it is 0.40%, then from sixth year it is 0.8%. Okay, 0.8%. Then O&M 1% for initially 1 to 5 years, then 1.2% for 5 to 10 years. Depreciation we are adding 0.3%. Then income at the rate of, I'm discussing for this Kusum Yojana or whatever you can say, 3.14 if, per unit rate is there. How much the revenue generation will be there. The net income by reducing this one, O&M expenses and depreciation and degradation. Then the total income is this one. Okay, so payback is calculated around coming 6 years, 6 to 7 years or 8 year maximum. The payback for this 1 megawatt or 5 megawatt or whatever. But what require regular cleaning of solar panels should be done. Regular removing, repairing of any hurdles affecting the solar unit generation should be done. Necessary steps for precaution measures for the solar project site should be taken. Okay, all these things should be done. Shadow effect should be removed. Shade to be removed. Shade to be removed. Installation of solar cell, solar unit at the time of installation as well as during regular course. If bifacial we are using, so then we should remove the grass or all these things. Or any if you even some are doing PCC there and white paint, they are doing white paint to gain the maximum this bifacial okay efficiency. These are just a sample. You can see what are the rate are going on in the market. It is what is the rate bidding around 4.05 3.69 yes 65. Okay, right. Next we can see this is just simple. You can see okay. War is the number one manufacturer of the solar panels, 13 gigawatt by 2000. This 25 and I am saying 13 gigawatt reliable. Okay, all these are the major companies. These are involved in the panel manufacturing. Data centers. Now we all know if we search on Google and if we search AI like ChatGPT or whatever, these AI tools searching consume 8 power per second. Okay, and there another thing is that the cooling cooling. The coming time will be the huge data centers will be there. 50% data centers will be increase. So when these data centers will be increased in coming time, at then their power demand, energy demand will be there. Huge energy demand. Are we able to cope up that demand? That is also green energy, not the diesel engine or whatever. So that is also another point. I'm just showing you what is that one. Data centers, how much power they consume. Their cooling is cooling power means this HVAC system, you can say, huge power consumption is there. Servers, whatever the server, we are just surfing on internet, but the servers, the AI based servers is there, they are consuming huge power. That should be through green energy only. Okay, this simply I am showing here summary of Telangana's clean and green energy policy. Okay, uh, everywhere they work, even they are coming geothermal, energy storage and hydrogen. They are coming. Okay, and incentive you can see either capital subsidies up to 25% for solar, wind, and electrolyzers. For green hydrogen also 20% for batteries. Okay, net SGST state GST reimbursement up to 100% for RE. No GST, 100% reimbursement. No transmission, wheeling, and CSS charges will be reimbursed. Means no wheeling charges for open access, no transmission losses will be there. Of the commissioning of solar and wind project. 100% electricity duty exemption for MSME registration up to 10 years. Means how the government is facilitating the green energy project or priority land allocation and stamp duty reimbursement. These are the basic why I am showing this one. Every state has some different type, but more or less we can say these are the facility capital subsidy and electricity duty exemption and GST exemption. Okay, and land parcel also there. Now the park is developed because the land is the very much issues. Also, government are allotting the land for the mega solar and wind projects. Okay, implementation and policy duration. Okay, all these things. Here I am showing this is the solar carport charging station. We are also planning to install this charging station. You can see how this the battery energy storage is there. Okay, you can see this is EV charger. Through this a solar panel power is coming from grid. Then this storage it is charging through storage. It is coming. Then car is charging. Same here. Okay. So how the things are changing. Everywhere the battery energy storage system is shown. Here and here you can see. This is the product battery, how a battery things you just shown here. Okay, not much important for this today webinar. You just see here. Means a battery can be communicated. What is there? CAN port. What is we are using in inverter battery, but there is nothing. But everything you can monitor from the at cloud based at home itself. Okay. Duck curve. How many of you know this? What is this duck curve? I want to hear from you itself. What is this? It is discussed many times at professional platform. What is curve? Yeah. Duck curve is basically you are seeing here there was 6 a.m. to 9 p.m. Okay. So here means when demand is not there, okay, when demand is not there, at that time you can see the solar is there. When the solar is there, 9 a.m. to 12 p.m. or 3 p.m. solar is there. At that time, demand is less. When demand is high, means evening time and morning time. At that time, solar is not there. So how this energy can be released through storage for potential for grid stability. This area is the potential for we have to maintain because solar is not there, but demand is high. How you maintain the voltage will be dipped. How you maintain this one? You have to go with the storage. That is that you want to this the curve. They want to show you this one. Okay. These are the carbon footprint means 20% energy consumed by industry, road transportation 10%, okay, building 6.4%. These are the footprint very clearly it is shown very electricity and heat 18%, highest electricity and heat consumption. Agriculture is also 15%. This is simply a template of the solar module. Yeah. Here you can see solar power plant and solar thermal. Already I have told the okay solar chimney, linear pressure, parabolic trap. I already told you. The same thing is there. Rankine cycle. We need not to discuss. Here you see orientation. Okay, what is the difference in the mean annual radiation gain in Central Europe or mean annual radiation gain in Southern Europe? Simple fixed optimum tilt angle. Okay. Then horizontal north-south axis, 11.5%, 17.4%. In area itself, it is changing. Okay. This is the southern or this is the central. Then 30-degree tilt axis difference. You can say how efficiency is different from the area wise also. Okay. Module tilt 50-degree and bifacial tracking. So tracking, you can see how efficiency we are getting. Radiation gain, 27.2% radiation gain is there. And here is the 34%. That need to understand this is the fixed and orientation, bifacial tracking. This is the single axis tracking. This is the tilted. This is the horizontal. Module type monocrystalline, we know very well. Most efficient technology or efficiency around 18%, commercial to 28% research under multicrystalline silicon. 24% we have just studied. Multicrystalline silicon cheaper and monocrystalline silicon, but also less efficient. Polycrystalline, multi means polycrystalline, same thing is there. Thin film, another reason. Thin film is cheaper than crystalline silicon, but less efficient. Everyone know various metal, amorphous silicon, cadmium, telluride, copper, okay, indium. These are the product. CSP, you just see here. Okay, I just want to show you. This is the parabolic trap technology. Solar thermal with parabolic trap technology. This is the central tower or central receiver. Heliostat are there. Sun radiation reflected and go to the top. Here is the steam generator basically. Okay, heliostat. These mirrors are called heliostat. These are the parabolic trap because they are safe in the parabola. This is the disk Stirling engine. Okay, there is an engine basically, maybe 25 kilowatt. The heat radiation comes into this, they reflect here, the heat of this gas, and the engine is generate the power. This is a linear Fresnel, straight, flat mirror basically. This is the tube, water tube. From this way and this way, the heat is reflected and heat of this water and the steam generator, then the Rankine cycle. This is the this one. Here you can see. This is the thermal storage basically. Okay. This is the parabolic trough. Very easily you can understand. Okay, a heat exchanger, steam generator, you can say, or whatever. Then this steam is a steam turbine generator. Then the condenser water is condensed, and then again feed here steam generator. Okay, water conduction, radiation, and convection through this steam is produced. Or this is basically not. This is not. This is shown directly water, but some heat transfer fluid is also used to sustain the temperature. That is not shown here, but that actually that one. Okay, heat transfer fluid, air vapor that you can see. Okay, now any solar project you want to plan, what you have to do, plant concept and simulation of electricity generation. That you have to do first of all. You have to simulate the situation, radiation, what they are, topography, how the overall ambient is there, temperature, wind. Okay, all these data we require. Then simulation is done. Accordingly, how much the generation will be there. According the revenue will we will come to know capex. What will be the capex and opex will be there. Then modeling of the project of economics. Accordingly, we do the modeling different scenario by simulating the different situations. We will come to know this project will be viable or not. Okay, so net present value, internal rate of return IRR, okay, NPV and levelized cost of electricity. That only we will come to know about the lifespan of the project, 25 years. Here you can see, okay, this is south, this is the zenith, you can see. Different zones, as collection loss. How is the collection loss? LC, PV area losses, system loss, inverter, whatever the losses happen in 2 and 2.5% around, that is called system loss. And power, this radiation collection loss, maybe due to tracking or you have not cleaned the modules, that is called PV area losses. Okay. And another one is the produce usable energy inverter output. Okay. That is graph is shown here. Different technology, thin film, polycrystalline, monocrystalline, and parabolic. It is compared with the parabolic actually. Here you can see, okay, cost of electricity in euro per kWh. In thin film, how much? Here you can see. This cost is high in the parabolic thermal technology, but yes, we should discuss this one. In monocrystalline, the cost is less. Poly is high. If we did double axis is double axis is high, single axis less. Okay. O&M cost changes. Okay, change of LEC, that is not sensitive to ambient temperature. Different scenario it is given. How the temperature will impact, how this DNI will impact. Okay, all these things. Land cost. Another thing is the technology, but means no journal. You know, where you want to install the project. It doesn't mean you simply go and install the project. You have to study everything. It's not what technology we are going to use. Okay, what is the levelized cost of energy? What is the O&M cost? What will the revenue generation overall? Technology selection, topography, irradiation, global, direct, diffuse, okay, everything. Grid in conditions means grid condition is also there. Are Gujarat, we can say the grid is stable. Okay, other state we see even at discom level they are stable, but in other state like Rajasthan and either Maharashtra also the at discom level grid is not stable. Tripping is there, more outage is there. Okay, so design optimization required for each project through project development and due diligence process, reliable design, bankable EPC and O&M contract, performance and plant acceptance criteria, all these things. Okay, reliable yield forecast. These are the various stakeholders you can see. Investor, insurance company, management, service company, EPC contractor, developer, lender, utility means discom or whatever, get this STU, CTU, all these things. Okay, Abhi, what we are doing, we are taking 5 minute break. Okay, I think you are continuously, there are more and more slides are there. I think lot of people have left. Anything, Maria, Mr. Maria, why you are leaving here? Can you unmute? Mr. Maria, I think he is not here. He has joined, but okay. Mr. Suresh Babu,
सर बोलिए सर।
अरे यार, you are learning or not?
अब बोल रहा है सर, हम लर्न कर रहे हैं।
Huh? Dinesh Dan, yaar. Dinesh, I have given you the responsibility. Yaar. You are leaving. Okay, no issue. Maybe I am giving 5 minute break to all of you.
ओके।
Okay,
Hello, sir. Hello,
you
hello,
just
sir.
you all go take water. I am also taking water, and
So, sir, I'm not
we
left. Sorry.
pardon. No, no issue. So I am doing 5 minute break only. That is right now 21:17. Okay. So we will start by 23. Okay.
ओके।
9:23. We after 5 minutes only we will start again. Okay.
ओके।
Yeah.
Okay, sure, sir. Sure.
Yeah. Yes, we are starting.
Okay, sir.
Yeah, yeah, 1 minute. Okay, let's start. So this is the typical project constellation. Simple, I have already told you. These are the various stakeholders basically. Okay, in any project, either it is solar or other project also. Lender who give the loans. Okay, investor equity means their own money. Insurance company to the management for operation contract, service companies who take the O&M contract, EPC contract to install the project, power purchase agreement that with the utilities, STU, CTU, SECU, whatever. Okay, developer who develop the customer can say. Pre-financial close due diligence, how it is done. Okay, project structure and obligation of project parties, solar radiation measurement, such as layout. 1 minute, sir. हेलो, अरे खाना रख देना यार मेरा, ठीक है? ओके, हाँ, ठीक. Out grid connection, civil works, energy yield, analysis through PV system, suitability of site, radiation, temperature, site complexity, soil conditions, because foundation is also a cost, piling or whatever, that is also cost. So soil condition, how it is, the condition is there, because you have to also. There is a not level, then cutting filling will come more. That is also again a cost. Project agreement including EPC agreement, PPA, O&M, technical and administrative operation, adequacy of the technical warranties, verification procedures, involved parties. Okay, QC, QA concept means quality checks, you can say, quality assurance, permit and licenses, project insurances, time schedule. Okay, project schedule, project management, risk management is very risk mitigation plan and risk management. That is much, much. If it is done in initial phase, itself, we can save a lot of money. Okay. Financial model, elaboration of model, provide input data, and financial advisor model, analysis of project sensitivities. It means risk assessment. Okay. Construction monitoring, compliance with contract specifications as per contract. Our DPC developer or whatever they are doing or not, quality is there, quality they are quality compliances. Okay, all the standards whatever in the supply of the material also. Okay, that is seen. And review of EPC contractors on this progress report, site and workshop inspection, preparation of monthly or quarterly progress report. Well, these are the part of construction basically. What to be done? It is not simply means you have a team basically. Someone do the due diligence of material at vendor workplaces, vendor quality team, EQM. Okay, and another is a site quality team, SICA. That is a site inspection and quality assurance. That is also there. That is also done. And other team is that the project itself. Okay, auditors also there who check the vendors are doing timely completing the work or not. That is another thing. Certification of completion, review and commissioning of the trial. These are the works basically testing completion certificate. And some carry out again monitoring during the project when the loan sections at that time carry out annual site visit, okay, preparation of semi-annual operating status reports, all these things and the due diligence. What is the due diligence during the construction phase? That is much important. A combined cycle not used for us, but yes, you just see this one how it is combined cycle means with the thermal power plant. How we can this solar thermal and that coal thermal, how that can be combined cycle. This is the financial calculation, levelized electricity cost. This is the formula basically. Okay, you can get anywhere. This is no okay. Yeah. These are the DNI, direct normal irradiance. Another is a diffuse. Okay, one thing is a global horizontal irradiance. That is a solar PV that they receive. Another is a diffuse. How to measure the diffuse radiation? Actually, there are meter. One is the pyranometer. Other is a pyranoleonitometer. Okay, so how to measure the diffuse basically? Anyone can diffuse radiation. How to measure the diffuse radiation? Global radiation is plus direct. This is the sun. You can see sun radiation. This is the direct. But another is radiation going to maybe Earth surface. And this is the on horizontal plane. Okay, this is the normal plane. This is the horizontal plane. You can say. Want to know how this diffuse radiations are measured? How? Anyone can tell? Diffuse, how to mean this? A pyranometer is basically used. How this is used for diffuse? Okay, used. Okay, one disc is used with pyranometer. Then this diffuse radiations are measured. MPPT, everyone know maximum power point tracking. Okay, understanding the MPPT how it works. It is technology, algorithm through algorithm only, not the tracking. Actually, tracking is not disturbed here. There is no physical changes is required. MPPT is work totally on algorithm, means use solar inverters to ensure the solar panels work at their most efficient point to generate the maximum possible power. MPPT why needed? Solar panel produce electricity based on sunlight intensity, temperature, and load condition. The power output of solar panel is not constant; it varies throughout the day. The maximum power point is the specific point on the solar panel's power curve where the combination of voltage and current produce the maximum power. Through algorithm only, basically according to the power is generated more. How you can see here. Okay, panel. This is a definition only. The MPPT algorithm in the inverter continuously monitor the solar panel's output. What is the output? Voltage into I, V into I, any power, voltage into current. Okay, so the power curve of a solar panel shows how power changes with the voltage and current. How it is done? Just simple example. You see, measure voltage and current of the solar. What MPPT do? It measures the voltage and current. Then algorithm controller calculate the maximum power point by analyzing the voltage and current relationship. Adjust the solar panel voltage to match the calculated MPP. Okay, it adjusts basically the voltage of the panel. Means there is no physical changes. Here example is shown just like a cycle. You can see pedaling speed, the rate at which you pedal, that is the pedaling speed. Bicycle gears, the gears represent different load condition. To ride efficiently, you change gear to match the terrain, uphill, downhill, flat road. You change the gear. If you stay in the wrong gear, pedaling becomes hard and you lose energy. If you want to save energy, at what gear the cycle should be. That is the same thing MPPT. It is a good understanding. Whoever done this one, it's a very good example. pedaling of a bicycle can be simulated just like a MPPT, maximum power point tracker. So example also you can see here, this one, maximize energy harvest, adapt challenging conditions, okay, increase system efficiency. When MPPT is most effective, cloudy or partially shaded days, cold temperature, morning and evening, because at that time already sun is not there. You have some, we are not getting, at that time optimization happen through MPPT. It is good for us. Okay, simple through example you understand. If a solar panel produces 200 volt and 5 ampere under current condition, whatever the condition is going, it is this. So maximum power V into I, 200 volt into 5 ampere, 1000 watt it will generate. Now, without MPPT, what will be the scenario? If the panel operated 150 volt and 4 ampere, okay, what will be the power? It will be 150 volt into 4 ampere, 600 watt. So we are losing 400 watt. So this is who changed this one. Means current and voltage is changed. It increase here, the voltage is here the 150, it is done 200 watt, 4 ampere, it is 5 ampere. This is only changed by the MPPT. Okay, through algorithm. Ensure operation at 200 volt 5 ampere, extracting full 1000 watt. Okay. 27 January means before 2 days, MNRE, Ministry of New and Renewable Energy, has declared that enforced quality standards. Now, not only in the installation quality, now the material quality, everything is the standard is defined. There is a penalty basically. So, by 27 January 2025, means before 2 days, enforce quality standards, ensure reliable performance of the renewable energy equipments, all in solar PV modules IS 14286 design specification, where, and another is the IEC 6173, is the safety standards, safety qualification. Okay, so minimum efficiency for monocrystalline is fixed 18%. If there is, it is lower, you have to accrue the penalty. Same for polycrystalline, it is 17%. Inverter should follow this IEC 61683 efficiency measurement. Means the loss should be limited. Okay. And another is the IS islanding 16161 islanding preventions. Means do not cut from the, like in WTG there are HVRT, LVRT, wherever the high voltage or where is a low voltage, it will not go in islanding. It remain with the grid. Okay, they're right through that situation. Same, the inverter should be like that. Should follow the islanding prevention. Okay, so that is the requirement is given. It is not if the plant is running and inverter out that particular you are getting, for example, 4 megawatt. Immediately you cut 4 megawatt because inverter is came in islanding mode. No, it should not happen. Again, storage batteries also there is a condition. IS 16270 general requirement and testing requirement is defined. Quality control process that is defined. And BIS, Bureau of Indian Standard, is will notify all agencies where testing to be done. Okay, whatever the lab are approved by the BIS is that nodal agency for all these things. Okay? Bureau of Indian Standards. These just on 27 January it is released. Compliance requirement. Compliance mandatory for manufacturing, who are manufacturing the solar or inverter, whatever, importing, for import also, or for sale also. Someone from our this PIETS were asking me, is there any requirement of BIS for the inverter, for this PCS, power conversion system, which is used in the, which is just like an inverter or converter. So now it is clear, yes, BIS is required, and it is defined also. For detail, you can see. Okay, if you require, I can share the link also. Testing and penalty, PV modules, design, type approval and safety validations, inverter efficiency and safety testing, batteries, durability and safety compliance. Non-compliance is there subject to penalties. All detail is given in the order released on the 27th January. This is the installation already I have told, but okay, again I am discussing here. Site feasibility and planning, land identification, feasibility study, solar resource assessment, irradiation, setting analysis, environmental regulatory compliance check, soil testing and geotechnical analysis, land preparation and then civil work, land leveling, grading, soil compaction, load bearing test, design mix, preparation, trial mix. Trial mix or design mix is difference. Design mix means what type of raw material you are going to use, aggregate, sand, water, what are the source you are going to use. If you have done the M25 is the design, for example. Now if you change the source, okay, then again you have to do the design mix, yeah, mix design, whatever. And once design mix is done, because each and every raw material, aggregate, sand, water, everyone is tested it, means NABL accredited lab. Then a mix design is done. Okay, and after that one on that mix design, a trial mix is done at site, and cubes are filled and then cube are tested. Okay, after 7 days or 21 days. So if result are satisfactory as per that design mix, then we found it is okay. Okay, after that only the this foundation work starts. Piling for module mounting structure, material procurement, another solar PV modules, DCR or ALMM approved. We should know where the DCR required or not required, ALM required or not required, module mounting structure, fixed or tilting or trekking, which type we have to the inverter duty transformer selection and procurement, inverter string central, hybrid 33 kV underground, overhead cable, VCB, all these things, AC/DC cable, BOP metal, then installation. You all know this, inverter term ICR complete. You can say with SCADA system and AC/DC cabling and solar DC cabling module to module, that we need to connect string combiner box, MC4 connector, all these things you know very well. Pre-commissioning checks, testing, all these things before commissioning, and grounding, earthing, lightning, that to be done. Synchronizing grid, final inspection, performance validation, regulatory approvals, load flow system study also to be done. Then how to hand out take off. Okay. These are the percentage only. Site feasibility planning is the 10%. I just bifurcated. What is the role of particular thing in percentage? Measure the material procurement is all not simple. 20%. And electrical mechanical installation is the 25%. And our operation 5%. This is the PM schedule. You all know. PM checklist, direct switchyard, main control room, MCR, string, current and voltage monitoring. Okay, what activities of maintenance you can see here. Daily PM checklist for IDT, transformer, weather monitoring system, ABT meter, isolator, whatever. Here is shown what to frequency. Daily you have to check what is the plan and actual. Plan, yes, actual done or not. We have to do. Okay, same for the string, and then daily record register, safety checklist, inverter for string, INV, peripheral, MC4, alarm, communication port, temperature, gravel, rig monitoring, conduit, sealing, whatever. Module cleaning, that is important. That is monthly. Module cleaning, hose pipe healthiness, pressure, leakage, if motor pump healthiness, if there is no robot for that problem. Inverter duty transfer, cleaning, tightness, breather condition, silica gel, UPS maintenance, you can say, ACDB, ST panel, SCADA, semi LA, okay, ST panel, all the RTCC, okay, right. These are some registers to be maintained: security register, inward register, outward register, daily maintenance register. Okay, these are things. ALMM, what is this one? Approved list of modules and manufacturing. Manufacturer must apply for the to the ministry. Means if you want to manufacturing or you are adding any other module, okay, and you want ALMM certification, this is mandatory. Okay, without that you cannot sell for the that customer who are like government subsidized project like Kusam Yojana, or maybe Pradhan Mantri PM Suryoday Yojana, or maybe open access projects are there. So they need ALM, or it takes time. Or you have to process, means first of all you have to test at any NABL accredited lab. You have to test your all modules. Okay, then you have to submit to BIS. Then after BIS certification, you have to apply to NICE, National Institute, which is the authorized institution. They come in for inspection. If they approve, then from through the MNRE you get the LM certification. Simply here they are shown. Manufacturer must apply to Ministry of MNRE. Products undergo technical evaluation based at IEC or BIS standards. The process will be factory inspection, quality verification, performance testing at NABL accredited labs. Final approval is granted by the fulfilling documentation is also required. All these things. है ना? Agency MNRE है, Bureau of Indian Standard, NICE and NABL. Fees application 5 lakh है ना per model. Testing fee varies in the NABL lab. Annual renewal fee 1 lakh. Additional cost may include sample testing, site inspection. Site inspection is also a cost. I think 1 lakh cost is there. Site inspection 1 lakh or 2 lakh per site visit. The certification charges. Time period it takes around 6 to 12 months. If you want to going for any factory or whatever, you are adding any module, then you have to initiate in time. Importance and compliance, only LM approved manufacturer can supply module for government projects and subsidy based installation. That is much important. And DCR certification is also jewelry. Key information on DCR, domestic content requirement. What is DCR? DCR requirement in solar PV. Mandatory domestic content uses for certain government-backed subsidized solar project. Include solar PV modules, solar cells, wafers, and glass. All these materials should be India made. Okay, if you are using in a Kusum Yojana or in any central public sector undertaking or other schemes, government scheme, any other government, state level also. Ensure Indian manufacturers get preference in government-supported solar projects. MNRE, SECI is involved in that one. Okay, what BIS is there. DCR portal is digital platform managed by MNRE for tracking the compliance. Manufacturers register their products and receive a DCR compliant certification. Okay, that is also another thing. DCR, just like ALMM, DCR, now a DCR portal is there. So, if you are Indian manufacturing, so then you have to take the DCR certification. There is a separate single window, DCR portal is there. You go there, submit the documents, get all compliances clear, then you will get this DCR document. Then only you can use these models in the subsidized products. Okay. Regular audit and verification are also conducted to ensure common. Time frame and fees. The registration process takes 3 to 6 months based on testing and verification. Testing team may be depending on the annual renewal is required. And then again annual ALM like that. This is DCR is also required. Importance of DCR reduces reliance on imported solar modules, supports local manufacturing and job creation, ensure high quality standard and reliability of domestic solar components, boost India's self-reliant Atmanirbhar Bharat. Handover takeover. Whenever you are doing handover takeover, okay, what you have to factory acceptance test, FAT, that should be taken, and site test reports. All site test reports you have to collect. Okay, what are the tests are? Material reconciliation should be done. Billing reconciliation should be done. Supplier warranty guarantee document should be taken. Hand over all balance material as per the purchase order. If it is given like any spares is there, that to be collected. Spares supplied by OEM for various equipment, that to be collected. As-built drawings, all approval copy, statutory approvals, contact list measure where the like LDC, grid side, okay, our HO people, or who are the engineers, commissioning engineers who have done the commissioning, that contact number should be there with email ID. List of keys, software settings, all software relay settings, SCADA, that should be taken in the laptop. All equipment, O&M manuals is necessary, especially if inverter, you can say, tracking system is there, okay, transformer is there, BCB is there. That type major equipment manual is also required when there is a problem. Okay, punch point closure, that is a different thing. Any specific issues faced during project stages, that should be also noted down. Means whatever the drawing, as per drawing, it is not done because some issue came, it is changed as per the site condition. So that should be noted there. A list of recurring cost means like some connection is taken, like SLDC, the lease line is there where you have to pay them. Okay, according quarterly you have to pay. Some land charges is also there. That we need to understand what the monthly expenses are coming. or yearly what to be done. PLI scheme boost domestic solar PV manufacturing and reduce import dependency. Total budget 24,000 crore. Tranche 1 4,500 crore. Tranche second 19,500 crore. It is the production linked incentive, basically to boost or promote the our India manufacturing. Total capacity 48,037 megawatt awarded under PLI scheme. Key incentive linked to local content, higher for full integration. Okay, polysilicon module. Investment attracted 35,000 crore. Employment generation 10,000 plus direct job created. Impact strengthens energy security, promotes innovation, and positions India as a global solar manufacturing hub. These are okay. Just you can take. I will share either. These are the material cost is also here. Like you can see here. Erection. What is the cost for installation cost? Everything is shown here. For a solar PV plant, these are different modules is there. Cable. Everything is shown here. No? Pipe. What are the cost per unit? Here you can see the big list. Everything is shown here. If anyone want, I can share this. All items is covered. Everything. Lighting, cables, nothing is left. Even small fire extinguisher, portable type, okay, first aid box, danger board, different type tray. Now it is finished. Thank you very much. If anyone want to ask question, they can ask. Anyone? Any question?
Sir,
Feedback you can give the chat box. Anyone after that one? Yes, yes. Ask me. Yes,
sir,
tell me.
ये इसका PPT मिल सकता है ना सर? PPT.
Yes, you will get PPT. Don't worry, I will share. Okay.
Okay, sir. Okay, sir.
Because many things I have not shown, na, though means not detailed. So I will share the PPT also. Don't worry.
Okay, sir. Okay, sir. Thank you, sir.
This time I am sharing the PPT also and recording also you will get.
Right, sir. Thank you, sir. Thank you very much.
Yeah. Any question?
तो स्टडी करके बाद में बात पूछेंगे सर.
Okay. The group is there. We can
Alright,
discuss after means anytime you can discuss. Also, you can talk one to one also. No.
Right,
worry.
sir. Okay,
This
sir.
is the facility in our case. You can get my number also. We are easily available. And okay, time maybe sometime if we are busy, I will just say after 1 day or 2 day or 2 hours, 3 hours. But definitely I reply. Okay.
Right, sir.
I receive the
Okay,
call.
sir.
And
Thank you, sir.
this will be also shared and recording will be also shared in the group. Okay, I think it's 10 o'clock. Na? Good. So you can give the feedback in chat box. No worry. I just opening the chat box. And thank you, Mr. Rizwan and Dinesh Dan taking the Mr. Tunde is here or left?
He is left, sir.
Okay. He was our guest actually.
Yes.
He is looking after this every time. What we will do means we will calling some influence person who are connected with our community and adding some value. But I also want someone today. Why I take the two names, Rizwan and because I want to develop you as a trainer. How to
Yes.
respond a query. Okay. So once you will start speaking, you can also develop yourself as a trainer in coming time. So
Sure,
anybody,
sir.
anybody who want like this, they can approach me.
Thank you, sir. Thanks a lot, sir.
Okay. Thank you. Great. I'm just checking the chat box. Much appreciate. Good. Okay. Thank you, everybody. Good night.
Good night, sir. Thank you, sir.
So, can how many percent? 16%. Can we on our video for 1 minute and just one clip we can take. It's only if we can come. I stop hinting. Yes. Okay, great.
Right, sir. Thank you, sir.
Mr. Salom Kumar ji. Good, good. Okay. Can I leave now, sir? Yes, yes, you can leave. No, no worry. Anyone can leave. Okay, thank you. Thanks to all. Good.
Okay, sir.
Right, sir.